All right, so in this lesson, we're just going to tie together a few things. We've already done most of the skills in this lesson. We need to talk about a few things on rates of change, but really I just want to, like I said, tie together some things. So arithmetic sequences, which you know that means you add or subtract the same thing every time, create discrete, separate points, linear graphs. So that should mean, right, if you're adding or subtracting the same thing every time, if my first term is 2, and I'm adding 3 every time, then my next term will be 5, add 3, let's see, 8, 11, and notice this is discrete because they're separate points, but it's linear because they're in a straight line. So you need to know that arithmetic and linear really mean very similar things. Those words should kind of go hand in hand in your head. Equations of linear, obviously, since linear and arithmetic are very related, remember when we wrote our arithmetic sequences, we had things that looked like f of n equals 2n plus 3. The rule for linear equations is that the x variable or n variable, whatever you're using, needs to have an exponent of 1, and so does the y. So a few things about linear equations. First of all, they can all be written in slope-intercept form, which is y equals mx plus b. Or what may also help you is to say things that are not linear. So some examples of things that are not linear. Y equals x squared. That's not linear because of this exponent of 2. Y equals 2 over x. That's not linear because x is on the bottom. xy equals 8. That's not linear because you have x times y. It's not okay to have that multiplied. So just know those things for linear. The only other one that I would add as can be linear, which sometimes tricks people, is y equals x over 2. It's okay to have fractions. We just don't want to have the variable on the bottom. And this is okay. Remember, we just said it can be written in slope-intercept form. We can write this as y equals 1/2 x plus 0. So that does actually work for slope-intercept form. And then the last little point that you want to make before we dive into some examples is that both, and when I mean both, I'm talking about arithmetic and linear, have constant rates of change. So to mean that we are going to add or subtract the same value every time between consistent points. So let's talk about for a minute how to calculate this rate of change when we kind of have some weird situations. Okay, so in this example, I just want to show you how to find rate of change and then how to determine if we have linear or an arithmetic sequence or not. So we're talking about rates of change here, and we talk about that in terms of like something per something. Remember, a rate is a per word, so we want to talk about or use that vocabulary. So we are increasing here from 3 to 4 years. If I just look at this first section, that's an increase of 0 cents for 1 year. So in that first section, we're just going to say that's an increase of 0 cents per 1 year. All right, if I go for my next section, though, you may notice that that is increasing. It's not staying 0. So in this next section, I'm increasing 2 cents. But on the top, I'm also increasing 2 years. Now, you always want to simplify that if you can. So 2 cents for 2 years is actually an increase of 2 cents. Well, I could write 2 cents for 2 years, or I could say 1 cent per 1 year. Okay, if I look at this next section, so this is going to kind of get overlapping. All right, here I'm increasing 3 cents in 2 years. So I'm still increasing by 2 years, but now I'm only increasing, now I'm increasing 3 cents. So if I write that out, that's going to be an increase of 3 cents per 2 years. Or if we simplify that, that'll be an increase of 1.5 cents per year. All right, and then the last section, hopefully you're getting the hang of this. This last one is going to be an increase of 4 cents over a period of 5 years. So we'll say we're increasing 4 cents over 5 years, or an increase of 0.8 cents per year if you divide that out. All right, if we don't have context, when we have a graph, you all already know this. To find slope on a graph, we're just going to count rise over run. So when they have points labeled for you, it's really not so difficult to find rise over run. So for instance, on this first example, if I zoom in here and we count rise over run, I'm just going to be going up. That's up 3, running 1. So this is going to give me a slope of 3 over 1, or just 3. Remember, this is increasing from the left to the right, so we want to make sure that value is positive. If we look at our next example, this time we are decreasing as we go from the left to the right. So I'm going to start at this top point here, the one most on the left, and I'm going to rise, which in this case is actually going to lead me down, and then run. So now I'm rising. Pay attention to what it's counting by. I'm rising from 3 to 0, that's negative 3, and then running in the positive direction, which is positive 3. So that's negative 3 over positive 3, or we always want to simplify that, negative 1. So here I've got a slope of negative 1. Now, 2 more questions that we want to talk about. If we find the rise of a horizontal line or the slope of a horizontal line. So we've already talked about this. The slope of a horizontal line runs side to side. That's horizontal, and that has a 0 slope, and you can remember that because of the z in horizontal, or because z itself makes a line that looks like that. But what I want to show you is that on a horizontal line, you're not rising any. So if we write rise over run, this is going to be rise 0, and then run, you could run however much you wanted to. You could run an infinite amount if you wanted to, run 5, run 7, whatever. If 0 is on the top, though, this equals 0. And if we talk about a vertical line, so this says find the run of a vertical line. So vertical, we know, goes straight up and down. And you should remember that this is an undefined slope. So if we find the slope here, when I go to do rise over run, I'm going to get rise an infinite amount, but I'm running 0. And you all should know that you cannot divide by 0. That's like one of those rules you learn back in middle school. And since you can't divide by 0, that's why this is going to be undefined. So you want to make sure that you know the difference between 0 and undefined when you work it out. All right, the last thing I want to remind you of, because you have seen this before in 8th grade, is just how to find the slope between 2 points. So we might have some examples or some problems that we encounter later on down the road, where they give us 2 ordered pairs, like 2, -7, and I'm just making up numbers here. Let's do 5 and -12, okay? Where we want to figure out what the slope is. And sometimes you could graph those and you could count rise over run, but there's this really nifty formula which comes in really handy, and that is m equals, and m stands for slope, remember, like in y equals mx plus b, m equals y2 minus y1 over x2 minus x1. And now, one of the things that you can kind of use to remember that the y goes on top, right? This is rise, and rise is a y direction. You're going like up and down. And then run is an x direction, so you're going to run left and right. So that way you can keep x and y straight. And then the other thing that I want you to notice is the 2 and the 1. So if you haven't learned this before, if you don't quite remember, the 2 means the y value from the second ordered pair, and the 1 means the y value from the first ordered pair. And sometimes I have people say, well, how do you know which one's the first or the second if they're not listed or whatever else? It doesn't really matter as long as you keep the x and the y from the first ordered pair kind of corresponding. So the first thing that I encourage you to do in any of these problems is just to label. Each ordered pair is always written xy. Right, that's how ordered pairs are set up. And since this is from the first ordered pair, I'm going to call this x1 and y1. And then if I do the same thing on this other point, I have x and y, but this is from the second ordered pair, so I'm going to call those x2 and y2. So when I go to solve my slope, I'm going to set this up. M equals y2, -12, minus y1, -7. Notice that I wrote this minus sign in addition to writing the -7. So you're going to write both of them, even if that second value is negative, or rather especially if it's negative. All right, and then on the bottom, x2, which is 5, minus x1, which is 2. All right, and then we're going to simplify, and this is something you need to be able to do without your calculator. Anytime you have this double negative, you want to change it to a positive, so I'm going to make this negative 12 plus 7 over 5 minus 2. And then we're just going to simplify top and bottom separately. Negative 12 plus 7 is negative 5. 5 minus 2 is 3. And since that doesn't simplify, I'm going to leave that as the slope for my final answer. So make sure that you have all of these examples and that you're ready to use them to practice this skill in class tomorrow.